I'm only going to talk briefly about the team round here to point out three sorts of situations you're going to run into. One of them is double counting problems, where you have to specifically avoid double counting any, reusing the same number. So for example, they may ask, how many different numbers are there? This does include sets, I believe. Let me take a quick look. Okay, how many different numbers are there that are multiples of 3 between 3 and 100, multiples of 5 between 5 and 100, or 7 and 100? Count up all of them and figure out how many numbers are in this combined set. Well, you've got 3 in this set, you've got 6 in this set, you've got 9 in this set, you've got 12 in this set, you've got 15 in this set, you've got 18 in this set, and so forth and so forth. And you have 5 in this set, you have 10 in this set, you have 15. Hold on a minute. We already have 15 in this set. So when you count, you have to make sure that you don't double count anything like the number 15. And so that's the sort of problem you're going to see here. Situations where you come up with a list, but you don't realize that you have counted something twice. All right? That's one sort of problem you're going to run into here. Another you will run into is process of elimination. So let's say they tell you that send plus more equals money, and each letter represents a different number, and it's your job to figure out which one is which. Well, first of all, if you're going to carry something onwards, m has to be 1. So you can mark m as 1. Oops. So that leaves you only the rest of the numbers to look at, okay? Now let's think about what it's like when you carry a number. Well, this could be 9 or this could be 8. But if it's 7, there's no way you're going to end up carrying 1. How do you know it could be 8? Well, this could be 8, this could be 1, and these could add up to enough. So s equals 9 or 8. And you can sort of eliminate things one by one. What could O count for? It could count for 0. Could it also count for like 2 or something? Well, if this is 8, and then it could add up, could it be, well, 1 is already taken, so could it be 2? Let's say this is 9 and this is 1. That carries into this, and these could add up to 1 more, but not 2 more, and 1 is already taken, so O is 0. So these really are zeros. And now e plus 0 is n. That means you have to have carried 1 to get, otherwise it'd just be e. So n is 1 more than e, and just sort of like building yourself clues like that one by one will eventually find you the solution. That means that you, well, could n be 0 and then you carried 1 onto here? No, because 0 is taken and 1 is taken, so you didn't carry anything over. That means s has to be 9. That means n, e, and y can't be 9. Great. Alright, so now we have to figure out if stuff was carried. Is n plus r e, or did we have to carry 1? Well, considering that n is 1 more than e, n is 1 more than e. Well, how do we get to e then by adding r to n? Well, we must be carrying, because there's no, even if this was like the smallest it could be is 2 because 1 and 0 are taken. So you add 2 to n and you end up with e. Well, no. So that means you have to have carried a 1 on. Oh, we already knew we carried 1 onto there. That means that r, since n is 1 more than r has to be at least 8. Yeah, because 9 is taken. So because we have to get to and e is almost all the way back around. So r could be 8. Let's see if r is 8. If this is 8, and we carried 1 from here also, then that could be 9 plus n to get to e. And then e plus 1 to get to n again. Yeah, since it's a 10 to get the whole way around, that's the whole way around. So that means this has to be 8. So r equals 8. It can work this way, it can't work if that's smaller. So now that we know that r is 8, well, we only have so many numbers left over. Also, d plus e have to add up to enough to get all the way around again. And y can't be any of the above. So what can y be? Y could equal 2 through 7. E could equal, could e be 2? Well, sure, then n would have to be 3. Could e be 6? Sorry, could e be 7? No, because then n would have to be 8, and 8 is taken. Could n, what could n be? Could n be 2? No, because then e would be like 1 or 0, so n can't be 2. Can n be 3? Well, then e would have to be 2, and that could theoretically work. So n could be 3 through 7. And how about, what else is there? Me, and then we also need d. What could d be? Well, d has to be fairly big, because we have to, like, even whatever e is and whatever d is have to add up to carry a 1. So since the biggest thing e is 6, and d has to be big enough to carry 1, the smallest d could possibly be would be 5 in order to carry 1 onward, right? 5 to 7, except for the problem that if d is 5 and e is 6, that would leave y as 1, because you'd have 11. That won't work because 1 is taken. So, d has to be either 6 or 7. Okay, could d be 6? Well, if so, e also has to be 6. And that won't work because they can't both be the same thing. So d has to be 7. Now we know that d is 7. That's starting to run out of, now we're starting to run out of numbers for these things to be. Y can't be 7, y has to be 6 at the most. N can't be 7, n would have to be 6. E can't be 6, because e has to be 1 less than n, so e could be 5. So forth. Process of elimination. That's why it's a team round, because you need a lot of brains there at once. Sometimes you can split up and that'll help things. A complement rule. Alright. This is the complement rule is the idea that if 20% is this, then 80% is not this. You can use that to play off each other. If you know that 3 numbers are in this group and 2 numbers are in this group and the entire world consists of 10 things, then there are at least 5 things in the not part of either group. Like paying attention to the group outside sometimes helps make calculations more easy than paying attention to the group inside. And that's the big ideas.